While the tech world is still buzzing about Apple's upcoming iPhone Fold, a $2,000 device rumored to arrive in 2026, Elon Musk just flipped the entire conversation. According to early supply chain leaks from Tesla and Starlink, a new Tesla Pi phone Fold, priced at just $179, is already in internal testing, and it's designed to wipe out every foldable phone in its path, including Apple's. What makes Tesla confident enough to enter the phone war at 1/10 the cost? How can a $179 foldable even compete with Apple's most premium lineup? And most importantly, is this the kind of practical tech you'd actually buy and use every day? We're diving into all of that, and more, in today's video. Before we dive in, hit subscribe and turn on the notification bell, because once this channel hits 17,654 subscribers, I'll unlock a special Pi phone Fold Easter egg, a never-before-shown comparison of Tesla's dual-rail hinge prototype versus Apple's upcoming foldable hinge design. It's a tiny detail, but it completely changes which device will survive daily use. This video pulls together everything we've discussed about the new Pi phone Fold. You might recognize a few points, but I promise there's fresh, important info you haven't seen before. So, relax and dive in. This is the video that connects all the dots. How is Apple's upcoming iPhone Fold a bold innovation? Or the company's most expensive mistake yet? Apple's first foldable iPhone, unofficially called the iPhone Fold, is shaping up to be one of the company's boldest and priciest experiments yet. According to multiple credible leaks, Apple is preparing to enter the foldable market in the second half of 2026, aiming to merge the portability of a phone with the usability of a tablet. Unlike the clamshell-style designs popularized by Samsung and Motorola, Apple's approach reportedly follows a book-style fold, opening like a mini iPad rather than flipping vertically. The device is expected to feature a 7.8-inch internal display when unfolded and a 5.5-inch external screen for daily use. Its thickness is where Apple wants to make headlines, just 4.5 to 4.8 millimeters when open and about 9 to 9.5 millimeters when folded. If these numbers hold true, it would make the iPhone Fold even thinner than the current iPhone Air at 5.6 millimeters, setting a new record for the slimmest foldable ever produced. To achieve that, Apple is rumored to use a titanium or titanium aluminum alloy frame, balancing lightweight with rigidity, a clear attempt to reinforce durability without compromising design. Inside, Apple is reportedly testing an under-display selfie camera, UDC, potentially removing Face ID entirely in favor of Touch ID, which would mark a major design shift for the iPhone lineup. The company is also said to be developing a crease-free flexible OLED panel and a high-precision hinge system, both aimed at delivering a seamless, premium experience worthy of Apple's brand image. But innovation like this won't come cheap. Industry analysts expect the starting price in the US to land between $1,800 and $2,000, pushing it well beyond the reach of mainstream users. While the device may unfold into a tablet-like display ideal for multitasking or streaming, its folded form is still nearly 9 millimeters thick, making it bulkier than most standard smartphones. Add in the usual concerns about screen durability, hinge longevity, and battery efficiency, and Apple's foldable dream starts to look more like a high-risk luxury bet than a mass-market product. What do you think about 2026 becoming the year of foldable phones? Would you actually want to own one? Or do you think it's just a passing trend? Comment yes if you're excited to see foldables like the iPhone Fold hit the market, and share why in the comments below. How can a $179 Tesla Pi phone Fold possibly outsmart the $2,000 iPhone Fold? The Tesla Pi phone Fold, expected to launch between $179 and $199, undercuts Apple's rumored $1,999 iPhone Fold by nearly 10 times. Musk's strategy is clear. Make the foldable smartphone accessible to the mainstream, especially for Tesla and Starlink users, and for emerging markets where Apple and Samsung remain luxury brands. The design follows a book-style horizontal fold, but Tesla's engineers have pushed for practicality over vanity. The Pi Fold is 20% lighter than Apple's expected foldable, weighing just under 220 grams, with a folded thickness of 8.8 millimeters and an unfolded profile of 4.2 millimeters, thinner than any major foldable currently in production. Inside, the 7.6-inch graphene OLED display runs at a blazing 144 Hz refresh rate with 2,200 nits of peak brightness, surpassing even the iPhone 17 Pro Max's 2,000 nits. The outer 5.4-inch panel supports up to 400,000 folds before wear, double the durability of Samsung's current hinge standard of 200,000. Performance-wise, Tesla is taking cues from its own full self-driving FSD chips. The new Tesla Neural Processor, TNP1, is based on the same architecture as the HW 4.0 chip inside modern Teslas, tuned for AI-driven efficiency. Early benchmarks suggest around 1.9 million points on Antutu, putting it ahead of Snapdragon 8 Gen 3's approximately 1.7 million. Running on Tesla OS, the system integrates Starlink Connect, Tesla Car Control, and Optimus Sync, allowing the phone to directly manage your Tesla, view autopilot cameras, or even track your humanoid robot. The AI-driven interface adapts to user habits, reducing power draw by up to 35% compared to Android-based systems. Furthermore, by designing the TNP1 chip in-house, the same way it develops the FSD computer for its cars, Tesla avoids paying up to 25 to 30% in licensing and chipset royalties that brands like Apple and Samsung usually pay to suppliers like Qualcomm or TSMC. Powering this entire system is a 6,000 mAh graphene battery, a leap beyond traditional lithium-ion packs. Instead of using lithium as the main active material, graphene batteries rely on graphene sheets, carbon atoms arranged in a single layer, that are 200 times stronger than steel yet incredibly thin and conductive. This structure allows electrons to move 10 times faster than in conventional lithium cells, drastically improving both charging speed and heat management. With this tech, the Pi Phone Fold supports 120 watts wired and 60 watts wireless charging, meaning it can fully recharge from 0 to 100% in under 9 minutes without overheating. By comparison, even the latest iPhone 17 Pro Max and Samsung Z Fold 6 take around 30 to 40 minutes to reach similar levels on their fastest chargers. Graphene's high thermal conductivity, roughly 5,000 watts per meter Kelvin compared to lithium's 400 watts per meter Kelvin, means it disperses heat almost instantly, extending the battery's lifespan by 30 to 35% and keeping the phone cool under heavy gaming or AI workloads. Tesla also applies its automotive-grade cooling architecture, similar to what's used in Model 3 battery modules, ensuring consistent performance and minimal degradation over time. In real-world terms, users can expect over 1,500 full charge cycles before noticeable capacity loss, nearly double the durability of a typical smartphone battery. Combined with solar trickle charging via Tesla's nano-photovoltaic backlayer, adding about 15% battery every 3 hours under sunlight. This makes the Pi Phone Fold not just fast charging, but almost energy independent, a fitting reflection of Musk's vision for sustainable, self-powered technology. On the imaging front, the Pi Fold houses a dual rear camera setup, 50-megapixel main plus 12-megapixel ultra-wide, and a 24-megapixel under-display front sensor capable of 8K/60 frames per second video. Instead of relying on traditional image processing pipelines, Tesla uses TeslaCam V3 stabilization and vision AI, the same neural network tech that powers its autonomous vehicles, allowing real-time object and light recognition for natural image balance. Why can Tesla make it this cheap? While Apple relies on over 200 third-party suppliers and pays an estimated 25 to 35% in component markups, Tesla designs and builds most of its hardware in-house. The TNP1 chip is produced on the same architecture as Tesla's FSD computer, using existing semiconductor capacity at its Texas facility instead of outsourcing to TSMC. The graphene battery cells are manufactured within Gigafactory Nevada, using modified 4680 battery lines, bringing cell production cost down to about $38 per unit, compared to the industry average of $70 to $80 for lithium-ion packs. Marketing costs practically zero. Apple spends roughly $1.2 billion per year on global marketing and advertising, about $45 per iPhone sold. Tesla doesn't spend a dime. Musk uses X and Tesla's own online community for promotion, turning every product tease or meme into viral marketing. A single Musk tweet can reach over 150 million users in an hour, generating the kind of exposure traditional campaigns would cost tens of millions to replicate. Production is where Tesla's real advantage lies. Instead of building new factories, Tesla is retooling part of its existing Gigafactory production lines, using the same high-precision robotics that already assemble EV battery modules. According to internal estimates, that reuse strategy cuts setup and assembly costs by up to 42% compared to launching a dedicated smartphone plant. Even the Optimus humanoid robots are expected to handle repetitive assembly tasks, reducing labor costs to under $3 per phone, far below the $14 to $18 per unit labor cost in China's Foxconn facilities. Then comes the ecosystem. Tesla OS runs directly on Starlink Cloud, a closed-loop satellite network owned and operated by Tesla's sister company. Apple pays Amazon Web Services, AWS, up to $360 million annually to host iCloud infrastructure. Tesla pays itself nothing. By integrating Starlink bandwidth, Tesla avoids telecom fees and data storage costs, saving an estimated $15 to $20 per device per year in back-end operations. Add all that up, and the economics make sense. So here's the real twist. What most people see as a $179 stunt could actually be Musk's opening shot in the next tech revolution. Because for the first time, a company known for rockets and EVs is proving that vertical integration can crash the smartphone cartel, the same way the Model 3 crashed the luxury car market. Now I want to hear from you. Would you ditch your iPhone for a Tesla Fold if it really costs $179 and delivers all this power? What feature impresses you most on this upcoming? If you like where this is going, hit that like button, subscribe, and ring the bell so you won't miss our next deep dive. Right here on AutoGearshift, where tech meets reality. Smartphones today keep getting faster, thinner, and flashier, but weaker where it really matters. The batteries don't last, the glass cracks too easily, and every update seems designed to slow you down or track what you do. Elon Musk doesn't build things that way. Every product he touches, from Tesla cars to SpaceX rockets, follows one rule: independence, durability, and freedom from control. Feature number 1. Can a phone really survive 20 years? The Tesla PiPhone 2026 doesn't use the same soft aluminum shell you find on today's flagships. Instead, its frame is forged from a Titan aluminum matrix composite, a proprietary alloy derived from the 30X stainless and aluminum hybrid used in the Cybertruck's exoskeleton and SpaceX Falcon booster frames. Laboratory tests suggest this material achieves a yield strength of over 800 megapascals, roughly 40% higher than Apple's 7000 series aluminum, and nearly double that of conventional smartphone housings made from 6000 series alloys. This alloy isn't just strong, it's smart. By skipping paint or color coding, Tesla allows the surface to naturally generate a microscopic oxide layer when scratched. That oxidation acts like armor, sealing microfractures and preventing corrosion. According to aerospace engineers familiar with the material, this process lets the metal retain 98% of its tensile integrity after 10,000 scratch abrasion cycles, a feat no commercial smartphone frame has achieved to date. Temperature resilience is another game changer. Where most aluminum phones begin to soften at around 250 degrees Celsius, the Titan aluminum matrix maintains its rigidity up to 420 degrees Celsius, ensuring the chassis stays stable even under direct heat exposure or rapid cold-to-hot transitions, something SpaceX already validated for its orbital components. For many older, practical users, this isn't just an engineering flex. It's peace of mind. A phone that doesn't crack, warp, or fade means no yearly upgrade cycle, no fragile beauty that dies in 2 years. It's built to endure. And reportedly, it's the first smartphone ever certified under SpaceX's aerospace structural grade standard, making the Pi phone less a gadget and more a precision machine for life. What do you think? Comment 1 if you'd trade your iPhone for a Tesla Pi phone. Comment 2 if you still trust Apple's ecosystem more. And tell us why in the comments below. We're reading every thought. If this feature hasn't persuaded you yet, just wait for the other 4 coming. Feature number 2. Can a smartphone battery really last 25 years without fading? Tesla seems determined to prove that battery death, the silent killer of every modern device, can finally be eliminated. The Pi phone 2026 introduces a solid-state power cell derived from the same prototype battery packs being tested in the Tesla Model 2. Unlike conventional lithium-ion cells filled with flammable liquid electrolyte, Tesla's design replaces it with a ceramic polymer solid electrolyte capable of withstanding temperatures up to 350 degrees Celsius without structural breakdown. This new chemistry packs a volumetric energy density of 1,050 watt-hours per liter, compared to around 650 watt-hours per liter in current iPhone 17 cells, a 1.6 times increase in stored energy per cubic centimeter. More impressive is its endurance. The cell has been laboratory tested to retain over 88% capacity after 10,000 full charge-discharge cycles, which equates to roughly 25 to 27 years of daily use. For comparison, a lithium-ion pack typically degrades below 80% after just 500 cycles, or less than 2 years for heavy users. Charging speed borders on unbelievable, but is backed by engineering logic. Using a dual-phase modulated current protocol adapted from Tesla Energy's Powerwall 4 architecture, the Pi phone can reach 80% charge in 150 seconds and 100% in just under 5 minutes, drawing a peak input of 180 watts at 98% conversion efficiency. The solid electrolyte allows higher thermal tolerance, meaning the pack remains below 42 degrees Celsius even at full speed charging, far below the critical 60 degrees Celsius threshold that typically accelerates cell decay. Feature number 3. Can a phone really stay online without any signal? The Tesla Pi phone 2026 is rumored to break one of the final barriers in mobile communication: total independence from cell towers. Unlike the iPhone 17, which still relies entirely on carrier networks and offers only a limited satellite SOS feature for emergencies, the Pi phone integrates direct Starlink satellite connectivity for full, continuous data service anywhere on Earth. At the heart of this system is a 0.8mm ceramic phased array antenna embedded just beneath the Tesla logo, capable of dynamically tracking up to 12 Starlink satellites simultaneously in low Earth orbit at 550 kilometers altitude. This design gives the device a beam-forming accuracy of 0.2 degrees, ensuring stable contact even during movement or partial obstruction, something current smartphone antennas cannot achieve. In standard testing by Starlink engineers, prototype Pi phones demonstrated downlink speeds averaging 35 to 50 megabits per second, and uplink speeds around 20 megabits per second, with a latency of just 45 to 55 milliseconds. That's roughly 4 times faster and 6 times lower latency than Apple's satellite SOS function, which is capped at 8 megabits per second and limited to text-based emergency transmission. Tesla's model supports real-time voice calls, encrypted messaging, live navigation, and continuous data sync, even in areas completely devoid of cellular signal. Power consumption. traditionally a problem with satellite comms, is handled by a low-loss GAN amplifier module that reduces energy draw by 32% compared to conventional RF front ends, allowing up to 9 hours of continuous Starlink connectivity on a full charge. Feature number 4. Can a smartphone truly be private? Unlike the iPhone 17, which still depends on Qualcomm's Snapdragon X70 modem and Apple's cloud-linked Siri processing, Tesla has cut out every third-party dependency. At its core lies the Dojo T1, a compact derivative of Tesla's in-house Dojo AI training chip, redesigned for mobile use. Built on a 5-nanometer architecture and capable of 18 trillion operations per second, it handles all computation, voice, image, and biometric data directly on the device. Running on Tesla OS, a closed-loop operating system forked from Tesla's vehicle firmware, the Pi phone doesn't transmit a single byte of personal data to the cloud. There's no advertising framework, no telemetry logging, and no external API access without explicit user consent. All machine learning, from facial recognition to voice commands, happens locally through the Dojo T1's AI cores, which reduces latency by 43% compared to Apple's neural engine, while completely eliminating server-based tracking. But the most controversial feature isn't software, it's hardware. On the left frame sits a physical privacy switch, a mechanical toggle that severs the power lines to the camera, microphone, GPS, and modem simultaneously. When switched to private mode, these circuits are physically disconnected from the mainboard, not just disabled by code. No app, process, or even Tesla itself can reactivate them until the user flips the switch back. For older users, those who've lived through decades of data breaches, spam calls, and silent surveillance, this isn't a gimmick, it's reassurance. A phone that can't spy because its sensors are literally offline speaks to a deeper engineering truth. Tesla isn't selling privacy as a slogan. It's building it into the hardware. Feature number 5. Can a phone really cool itself like an engine? Overheating is the silent killer of modern smartphones, draining performance, aging components, and turning even top-tier flagships into throttled hand warmers. The Tesla Pi phone 2026 takes a page straight out of its automotive lineage, introducing an ultra-thermal cooling system based on the same liquid vapor plate graphene architecture that regulates temperature inside the Model S battery pack. At the core of this design lies a vacuum-sealed vapor chamber connected to a microliquid circuit that runs through the phone's titanium aluminum frame. Heat generated by the Dojo T1 CPU and Tesla's onboard GPU cores is instantly transferred into this chamber, where it's spread across graphene capillaries and dissipated evenly through the chassis. Internal testing data from Tesla Labs shows that under sustained 8K video recording, or 100% AI workload, the Pi phone's core temperature remains below 35 degrees Celsius, while the iPhone 17 Pro, under similar conditions, often peaks at 46 to 48 degrees Celsius before thermal throttling kicks in. The engineering difference is more than comfort, it's longevity. Lower thermal stress means up to 45% slower transistor degradation, 30% higher battery stability, and consistent frame rates even after hours of continuous use. More impressively, the system is rated to operate in extreme environments, maintaining full performance from -20 degrees Celsius to 60 degrees Celsius, conditions that would cripple most consumer devices. For practical users, especially men over 50 who prioritize reliability over specs, this isn't just cooling, it's assurance. A phone that doesn't overheat, doesn't throttle, and doesn't fail early is one you can actually trust. Feature number 6. How is Tesla building a foldable phone with EV-grade battery life that beats the iPhone 17 Pro Max? According to the latest engineering leaks analyzed by several battery specialists, the strongest advantage Tesla may bring to the Pi phone Fold is its rumored EV-derived battery system. While Apple is expected to push the iPhone 17 Pro Max toward a higher density cell, Some analysts predict a modest jump to around a 4,900 to 5,000 milliamp-hour pack. Tesla appears to be testing a compact, energy-dense module inspired by the company's 4680 cylindrical chemistry. Early reports describe a folded format battery with an estimated 6,500 to 7,000 milliamp-hours capacity, built with the same silicon-enhanced anode structure used in Tesla's mid-tier pack upgrades. If accurate, this would give the PiPhone Fold not just more hours on paper, but extended screen-on time that specialists estimate could reach nearly 18 hours of mixed usage. More interestingly, some insiders claim Tesla is pushing for a 70 to 80-minute full recharge, using a modified 65 to 70-watt charging controller. While Apple is projected to keep its charging speed conservative, most leaks point to the 17 Pro Max staying near the current 27-watt ceiling. The PiPhone Fold could realistically hit 50% battery in under 20 minutes, rivaling top-tier Android flagships. For viewers who constantly move between job sites, road trips, and vehicle integration, this difference is not theoretical. It means plugging in before a drive and having a fully operational device for navigation, remote vehicle control, and media without worrying about midday battery anxiety. But what's grabbing even more attention from EV analysts is Tesla's rumored thermal stability layer. Instead of adding more graphite padding like traditional phones, Tesla is said to be experimenting with a thin heat spreader, similar to that used on the Model Y heat pump system, designed to keep the battery within a stable 25 to 32 degrees Celsius window during heavy load. If this proves true, the PiPhone Fold would be one of the first smartphones that can maintain peak performance for extended periods, useful for gaming, 4K recording, and even Starlink-linked video calls in remote zones. Meanwhile, most foldables today throttle within minutes because of heat buildup in the hinge area. This is where Tesla's automotive background makes a measurable difference. Thermal engineering is already their specialty. Feature number 7. How could Tesla's satellite system deliver the one feature Apple still won't touch? One of the most persistent leaks surrounding the PiPhone Fold 2026 is its rumored integration with a scaled-down Starlink module, something experts have been dissecting ever since early PCB schematics circulated through supply chain trackers last quarter. While Apple is expected to expand its emergency satellite messaging on the iPhone 17 Pro Max, analysts widely agree it will remain limited to low-bandwidth SOS functions. Tesla, on the other hand, appears to be aiming for a much broader communication range. Reports suggest a compact 18 to 22 mm antenna array housed near the upper hinge of the foldable frame, capable of linking to a low-orbit Starlink micro node with a sustained downlink estimated between 24 and 35 megabits per second. Even at the low end of that range, it would surpass current smartphone satellite systems by multiples, enabling not just emergency contact, but full message syncing, navigation updates, low-res video calling, and possibly even compressed media pulling in areas where cellular towers completely fail. For users who regularly take long drives, explore rural highways, or work in construction sites far outside urban networks, this is not a small advantage. A phone that remains fully connected, even where your truck's dashboard signal drops to zero, changes the way you handle navigation, fleet management, or basic communication. Many analysts point out that Tesla already operates more than 6,000 active Starlink satellites. Even assigning a tiny fraction of that network to mobile devices would give Tesla an infrastructure advantage no other smartphone maker can replicate without negotiating with third-party providers. Apple, meanwhile, is still dependent on Globalstar partnerships, with limited global coverage and no promise of expanding to general-purpose satellite internet by 2026. The engineering challenge, however, remains the antenna and power draw. Some early teardown analysts estimate that a Starlink micromodule running at moderate activity could consume 2.5 to 3.1 watt-hours during transmission. High, but manageable, with a 6,500-plus milliamp-hour battery like the one rumored for the PiPhone Fold. That's precisely why experts believe Tesla is even exploring this feature. Their battery overhead gives them the room to support such real-time connectivity. Heat dissipation is another concern, yet some leaked prototypes reportedly show a thin graphite vapor chamber stretching across the foldable's mid-spine, helping the device maintain stability even during satellite handshakes. If this design is accurate, it would allow the PiPhone Fold to perform sustained satellite communication without thermal throttling, something current devices can't do without aggressive downscaling. The iPhone 17 Pro Max is expected to excel in camera upgrades and processor efficiency, yet it is unlikely to offer a communication feature this transformative. For tech users who depend on reliability in unpredictable environments, truck owners, frequent travelers, off-grid explorers, or anyone driving long distances, the advantage is clear. Tesla turns the PiPhone Fold into a communication device engineered for movement, not just entertainment. Feature number 8. How will Tesla's rugged foldable and vehicle integration create a category Apple can't compete in? The third feature rumored for the Tesla PiPhone Fold 2026, and the one analysts say might be its most disruptive, is its reinforced folding chassis paired with deep vehicle integration. According to multiple supply chain leaks, Tesla is testing a dual-rail hinge system machined from a lightweight alloy similar to the aluminum used in the Model 3's crash structure components. Early material reports describe tensile strength measurements in the 380 to 420 megapascals range, significantly higher than the 250 to 300 megapascals alloys typically found in current foldable phones. If these numbers hold, the PiPhone Fold could withstand drops, vibration, and hinge stress far beyond the durability standards of today's consumer foldables, which often fail after 200,000 to 250,000 folds. Several teardown engineers predict Tesla may target a cycle rating closer to 350,000 folds, roughly equivalent to opening the phone 150 times a day for more than 6 years. For people who work outdoors, travel frequently, or treat their gear like an extension of their vehicle, this type of structural integrity is more valuable than cosmetic materials. And this conversation is becoming even more relevant as Apple is reportedly preparing its own first-generation iPhone Fold for release next year. But analysts warn that Apple's debut foldable is likely to follow a slimmer, more luxury-oriented design philosophy, similar to the iPhone Pro line, rather than the rugged, tool-grade approach rumored for Tesla. That means durability benchmarks may land closer to mainstream foldables than the vehicle-inspired materials Tesla is experimenting with. In other words, even with Apple entering the foldable race, the two companies may still be targeting completely different user segments. What makes the Tesla rumor even more compelling is how the PiPhone Fold is reportedly designed to link with Tesla vehicles at a system level. While Apple aims to deepen CarPlay integration in the iPhone 17 Pro Max and may extend some of those features to the upcoming iPhone Fold, the PiPhone Fold is expected to function more like a native Tesla component. Insiders claim Tesla is preparing an ultra-low-latency Bluetooth and UWB hybrid connection that would reduce phone-to-vehicle command time to under 90 milliseconds, nearly half the latency of current smartphone key systems. That would allow the PiPhone Fold to serve as a seamless digital key, remote climate controller, security monitor, and even an interface for upcoming maintenance diagnostics. Some software watchers believe Tesla might go further, enabling direct syncing with FSD navigation routes, so drivers can plan complex multi-stop journeys on the phone and push them instantly to the vehicle. Apple's CarPlay 2.0 is evolving, and the iPhone Fold will likely support it, yet it still remains an overlay. Tesla's rumored system sounds like direct integration with the car's core software. Add to this the leaks about a sunlight-readable secondary display measuring around 2.4 to 2.7 inches on the outer shell, specifically tuned for vehicle functions, and the PiPhone Fold starts looking less like a foldable smartphone and more like a multifunction control terminal for Tesla owners. This direction makes strategic sense. While Apple competes primarily in consumer tech luxury, Tesla is positioning the PiPhone Fold as a tool built for mobility, durability, and total ecosystem control, much like how the company designed the Model Y to dominate practical segments instead of chasing design awards. Analysts argue that even with the iPhone Fold entering the market, Apple still cannot compete directly in this category because it does not control the vehicles themselves. It relies entirely on partnerships and software layers. Tesla, meanwhile, owns the hardware stack from phone to car to satellite connection. So would you actually switch to a Tesla-built foldable, or do you prefer Apple's ecosystem? Share your thoughts below. We always read every comment. The tech world is buzzing again as Tesla, the electric vehicle giant, takes its rivalry with Apple to a whole new level. After shaking up the automotive industry, Tesla surprised the market by finally agreeing to support Apple CarPlay in its vehicles, a move that once seemed impossible. While the CarPlay integration won't replace Tesla's interface, it signals a shift in strategy. Tesla is willing to embrace Apple's ecosystem when it benefits users, all while maintaining its own edge. Could the lessons from CarPlay pave the way for Tesla to challenge Apple directly in the smartphone arena? Now, whispers suggest Tesla is preparing to enter the smartphone market with the PiPhone Fold 2026, rumored to cost under $169. Could this be the first time a non-traditional tech giant not only competes with Apple on features, but also undercuts them on price? And for tech-savvy users, will Tesla finally deliver apps and functionality that rival Apple's ecosystem, while keeping everything simple and affordable? How could Tesla PiPhone Fold 2026 undercut Apple while outperforming the iPhone 17? The leaked details on the Tesla PiPhone Fold 2026 suggest a device that is both ambitious and aggressively priced. Rumors indicate a launch price under $169, which instantly positions it as a game-changer in a market where the iPhone 17 starts at $999 for the base model, with the iPhone Fold variant projected to exceed $1,499. That's a price difference of nearly $1,330 to $1,400, a staggering gap that would immediately attract budget-conscious tech enthusiasts, especially those already familiar with Tesla's value-for-performance reputation from the EV sector. Tesla's approach appears methodical, leveraging lessons learned from its Apple CarPlay integration in vehicles. Just as Tesla found a way to incorporate Apple's ecosystem without surrendering its own interface, the PiPhone Fold could allow users access to familiar apps while retaining Tesla's proprietary features. For example, early leaks suggest that Tesla is focusing on a foldable OLED display, approximately 7.2 inches unfolded, slightly larger than the rumored 7-inch panel of the iPhone Fold. The increased screen real estate could offer a more immersive media experience, from streaming Tesla's own infotainment-inspired apps to productivity tasks, all without compromising portability when folded. Performance-wise, Tesla is rumored to adopt a custom AI-driven processor, optimized for low energy consumption, but capable of handling multitasking, gaming, and augmented reality apps. Analysts estimate that the PiPhone Fold may achieve processing speeds comparable to the iPhone 17's A20 Bionic chip, which peaks at approximately 3.8 GHz per core. Battery technology is another Tesla specialty. Internal leaks suggest a polymer sodium hybrid cell capable of up to 48 hours standby and 18 hours active screen time, potentially outperforming the iPhone Fold's projected 16 hours of active usage. If accurate, this could address one of the most persistent frustrations for foldable phone owners: battery endurance. From a software perspective, Tesla appears to be building a highly modular operating system, enabling compatibility with common mobile apps, while supporting Tesla-exclusive applications that mirror the features drivers already enjoy in Model 2 and Cybertruck infotainment systems. Unlike the iPhone Fold, which is expected to heavily restrict app customization to Apple's ecosystem, the PiPhone Fold may allow more flexible widgets, split-screen apps, and Tesla media integrations, appealing to productivity-focused and tech-savvy users who value control over limitations. Connectivity is another critical factor. While Apple continues to integrate 5G millimeter wave and satellite communication selectively, Tesla is rumored to include built-in low-power Starlink support, enabling reliable data connection even in remote areas, similar to Tesla vehicles staying online on the highway. This could provide a unique advantage for travelers, Tesla owners, and users living outside dense urban centers, a segment often overlooked by Apple's premium offerings. Which side will you be in this future battle? Just comment Tesla or Apple to let us know. Let's see which side has more fans. What features make the Tesla Pi phone fold? 2026 a true game changer? One of the most exciting aspects of the Tesla Pi phone fold 2026 is how it leverages technology familiar from Tesla vehicles to deliver a smartphone experience no other brand currently offers. Reports suggest the Pi phone fold will include a custom AI assistant integrated across both hardware and software, capable of managing tasks, automating routines, and even adjusting device performance depending on usage patterns. An evolution of Tesla's in-car autopilot AI applied to personal technology. By comparison, Apple's Siri on the iPhone 17 and the projected iPhone Fold remains largely app-limited and often struggles with multitasking commands, highlighting a potential performance gap. Screen and display technology are also notable. The Pi phone Fold is rumored to feature a 7.2-inch OLED foldable panel with an adaptive 120 Hz refresh rate for smoother scrolling and gaming. The device will reportedly support dynamic brightness from 2 to 1,200 nits, which could outperform the iPhone 17 Fold's 1,000 nits max. Early renders suggest minimal crease visibility, a problem that has plagued most foldable devices, including the iPhone Fold. For content consumption, streaming, gaming, or productivity, the larger and brighter display could offer a 15% more immersive experience, particularly in outdoor lighting or during travel. Battery and power management are central to Tesla's advantage. Leveraging advanced polymer sodium hybrid cells, Tesla reportedly achieves 18 hours of active usage and up to 48 hours standby, surpassing the iPhone Fold's estimated 16-hour usage window. Fast charging is projected at 50 watts, delivering 60% battery in just 30 minutes, versus Apple's 27-watt foldable charging projection. Tesla's approach reflects lessons learned from EV energy management, optimizing both endurance and thermal safety in a compact device. Software experience appears designed with the everyday user in mind, but with a Tesla twist. Users may benefit from modular app layouts, enhanced media controls, and direct Tesla ecosystem integrations, such as streaming music, vehicle diagnostics, and even real-time traffic or navigation data pulled from Starlink. Unlike Apple's walled garden approach, the Pi phone Fold may allow split-screen multitasking for 2 apps simultaneously, floating widgets, and customizable home screens, features particularly attractive to professionals and tech enthusiasts who value efficiency and flexibility. Connectivity remains another area where Tesla may outperform Apple. With built-in Starlink access, users could stay connected in rural or remote locations where standard 5G signals falter. For a road-tripping Tesla owner, this could be transformative, ensuring constant data access for navigation, streaming, and communication, something even the iPhone 17 Fold cannot fully guarantee outside major urban centers. How can Tesla Pi phone Fold disrupt Apple and change the smartphone market? Tesla's entry into the smartphone market with the Pi phone Fold 2026 isn't just about hardware, it's a calculated move to challenge Apple's dominance and capture market share by leveraging Tesla's unique ecosystem and aggressive pricing. With a rumored launch price under $169, Tesla positions itself to appeal to millions of potential customers in the US alone, who may find Apple's $999 iPhone 17 or $1,499 iPhone Fold out of reach. That's a strategic undercut of nearly 90%, putting Tesla in a position to attract first-time smartphone buyers. cost-conscious tech enthusiasts, and even existing Tesla EV owners who want their devices integrated into the broader Tesla ecosystem. The Tesla-Apple collaboration history adds another layer of intrigue. By successfully integrating Apple CarPlay into its vehicles without compromising Tesla's interface, the company has demonstrated that it can coexist with Apple's ecosystem while still asserting its own technological identity. This experience may translate into the PiPhone Fold, where users could enjoy Apple-like app familiarity while benefiting from Tesla-exclusive features such as AI optimization, modular apps, Starlink connectivity, and EV-linked functionality. This dual advantage, affordable price plus unique features, creates a potential wedge in Apple's market, especially for users seeking more than what the walled garden iOS environment offers. Tesla's potential market disruption is amplified when considering foldable phones. The iPhone Fold, projected at over $1,499, is expected to target a niche premium segment. In contrast, Tesla's foldable device at under $169 could democratize foldable technology, reaching a far wider audience and reshaping consumer expectations. Analysts predict that even if Tesla captures 5 to 10% of the US foldable phone market, it could translate into millions of units sold annually, an impressive figure for a company entering smartphones for the first time. From a global perspective, Tesla has the advantage of an existing fan base in EVs and tech, many of whom are male, tech-savvy, and early adopters, precisely the demographic most likely to embrace a new foldable device at a fraction of Apple's price. Coupled with Tesla's reputation for cutting-edge technology, energy efficiency, and bold pricing strategies, this could pressure Apple to reconsider its pricing structure, foldable adoption speed, and even ecosystem flexibility. Tesla may also indirectly encourage competitors to accelerate their foldable phone efforts, potentially sparking a new wave of innovation in the mid-range smartphone market. So, could the Tesla PiPhone Fold 2026 really give Apple a run for its money? Will its foldable design, AI-driven features, and Starlink connectivity make everyday tech life easier for Tesla owners and tech enthusiasts? What do you think? Would you switch from Apple to Tesla for your next phone? Share your thoughts in the comments below. After shaking the automotive industry with EVs and AI-driven interiors, Elon Musk is now setting his sights on something far more personal, the Tesla PiPhone Fold. And of course, Apple isn't sitting back. The iPhone Fold, expected to debut within the next 12 months, is rumored to be Cupertino's most ambitious project since the first iPhone. But here's the question: can Tesla, a car maker, truly out-engineer the world's most experienced smartphone company? How does the PiPhone Fold plan to beat Apple at its own game, from materials, battery life, to integration with cars and satellites? How can Tesla build a foldable phone that survives real-life use? When it comes to foldable smartphones, durability is the deal breaker. Samsung's Galaxy Z Fold 6, for example, uses a UTG, ultra-thin glass layer that's only about 0.03 millimeters thick, protected by polymer. Apple, according to multiple supply chain leaks, plans to use Corning's flexible Gorilla Glass Victus 3, rated to withstand 250,000 folds before showing visible crease fatigue. Tesla, on the other hand, seems to be taking a radically different approach. Instead of flexible glass, sources close to the Shanghai assembly unit claim the PiPhone Fold will use a liquid aluminum silica composite, a material hybrid first tested on Tesla's solar roof tiles. In lab simulations, this material handled over 400,000 fold cycles at temperatures between -20 degrees Celsius and 65 degrees Celsius, roughly 1.5 times more resilient than the Galaxy Fold's hinge glass combination. Why does that matter? Because real life isn't a lab, and the men in our audience know exactly what that means. You drop your phone on the workshop floor, use it under sunlight or in the garage while checking a torque spec. Not in a showroom, Tesla seems to be designing this phone the same way it builds a Model Y door hinge, for abuse, not aesthetics. Elon Musk hinted earlier this year that the Pi Fold's frame could be made from grade 5 titanium, the same alloy used in the Cybertruck's door panels, with each unit milled using CNC precision under 0.01 millimeter tolerance. If true, that alone would give it a sheer strength of over 900 megapascals, roughly double what Apple's rumored aluminum silicon frame can handle. Even the folding mechanism tells a story. Apple is rumored to adopt a U-shaped single-axis hinge, similar to what Huawei used in the Mate X's 2, thin, light, but more fragile Tesla. In contrast, has reportedly filed a design patent for a magnetically damped dual-axis hinge. The idea is simple but brilliant. Use electromagnetic resistance to smoothen opening and closing, reducing wear on flexible connectors. What's fascinating is that Tesla's hinge mechanism appears to share design DNA with the Cybertruck's adaptive tonneau cover motor, a component tested to handle up to 200,000 actuation cycles. In other words, this phone might just be the first foldable that can survive being opened and closed every day for 10 years without dying. And that's where Apple faces its first real test. Tesla isn't chasing fashion, it's chasing endurance. For users who value toughness, this could be the first foldable that doesn't feel like it'll snap after a week in your pocket. Which one would you actually trust to survive daily use? Comment 1 if you'd go with Tesla's tough titanium build. Comment 2 if you'd still trust Apple's sleek Gorilla Glass design, and tell us why in the comments, which one fits your lifestyle better. How can Tesla's display and chip actually outperform Apple's M-series tech? When it comes to pure processing muscle, Apple's silicon still reigns supreme, at least for now. The A18 Pro chip, expected to power the first iPhone Fold, is built on TSMC's 3nm process and reportedly pushes up to 3.9 GHz clock speed. It integrates a 12-core GPU capable of running up to 1.2 teraflops, which is massive for a smartphone. Apple also plans to integrate its Neural Engine Gen 4, pushing 38 trillion operations per second, tops, mainly to improve photo rendering and real-time language translation. Tesla, however, is not entering the fight with a conventional chip. According to documents leaked from Gigatex's R&D wing, the Pi Phone Fold prototype uses a custom Dojo Lite processor derived from Tesla's in-car AI chip. It's not just about speed, it's about adaptive learning. This chip reportedly operates at 2.8 GHz on the main CPU cluster, but features an onboard AI inference core that handles driver patterns, location-based optimization, and even energy balancing between the phone and a nearby Tesla vehicle. In internal benchmarking tests, as reported by tech insider Balaji from Clean Technica, the Pi Fold's AI core processed visual recognition tasks 42% faster than Apple's Neural Engine under sustained load. But with one huge caveat: it consumes more power. Tesla's engineers are still refining voltage regulation to prevent the chip from exceeding 35 watts peak under performance bursts, something Apple already controls elegantly within 18 watts. And speaking of displays, Apple is rumored to use a 7.8-inch OLED supplied by Samsung display with 2000 nits peak brightness, 120 Hz refresh rate, and LTPO adaptive dimming for battery efficiency. It's refined, but not revolutionary. Tesla, meanwhile, has been sourcing micro-LED panels from its solar glass division, a move that could change everything. Micro-LED, unlike OLED, doesn't rely on organic compounds that degrade over time. It means no burn-in, longer lifespan, and higher sustained brightness. Tesla's panel reportedly reaches 3,500 nits peak, with HDR dynamic contrast above 2 million to 1. Even more interesting, early hands-on footage from internal testers shows the foldable crease almost invisible under direct sunlight, something Samsung and Huawei still struggle with. What's truly Tesla-like is how the display interacts with the rest of the ecosystem. When connected to a Tesla vehicle, the phone automatically syncs its display mode with the car's interior lighting. For example, if your Model Y switches to night drive mode, Your Pi-Fold screen dims its white balance automatically to reduce glare. A subtle but elegant integration. On camera performance, Apple is betting on its periscope telephoto system with 5 times optical zoom and the same 48-megapixel Sony IMX903 sensor used on the iPhone 16 Pro Max. Tesla's Pi-Fold, on the other hand, takes an entirely different approach. Instead of chasing megapixels, it uses a dual 30-megapixel AI triangulation setup, each lens capturing from slightly different angles to feed 3D depth data directly to the Dojo Light core. This allows for real-time volumetric scanning. Think of measuring your garage or checking car paint defects using just your phone camera. How can Tesla's battery and charging speed leave Apple behind? Battery life has always been the invisible wall limiting modern smartphones. Foldables suffer even more. 2 displays, dual batteries, and more moving parts mean more drain. Apple's iPhone Fold, based on insider specs from the Cupertino supply chain, will use a 4,400 mAh dual-cell lithium-ion pack. It supports 45-watt fast charging via USB-C, and the company is working with Foxlink to integrate a new MagSafe-style hinge connector for wireless power transfer. Letting users charge the phone while it's folded flat on a MagSafe pad impressive, but Tesla's approach is far more radical. The Pi-Phone Fold is rumored to be the first commercial device to use aluminum-ion battery cells co-developed with Graphene Manufacturing Group, GMG. These cells, unlike lithium-ion, use an aluminum anode and graphite cathode, capable of charging from 0 to 100% in under 3 minutes in lab conditions. That sounds insane, and it is. But there's nuance. In real-world tests from Tesla's GigaLab in Nevada, the 4,800 mAh aluminum-ion prototype recharged from 5% to 80% in just 2.5 minutes using a 90-watt supercharger adapter. Compare that to Apple's iPhone Fold projection. About 28 minutes for the same range. What's more shocking is cycle durability. Traditional lithium-ion cells typically begin to degrade after 500 to 800 charge cycles, which translates to about 2 years of daily use. Tesla's aluminum-ion chemistry reportedly maintains 93% capacity after 2,000 full cycles, and its heat stability is remarkable. Internal temperatures remain under 38 degrees Celsius even when charged at 5C rate. Lithium-ion batteries are prone to thermal runaway, especially under high compression or external heat, like leaving your phone on a car dashboard. Aluminum-ion cells, however, don't suffer from lithium dendrite growth, meaning no swelling or explosion risks. For people who work in hot environments, construction sites, garages, or delivery routes, this could be a massive reliability win. Another practical advantage? Integration with Tesla's ecosystem. The Pi-Fold isn't just a phone, it's an energy node. When parked near a Tesla vehicle or Powerwall, the phone can wirelessly draw or send charge at up to 7 watts bidirectionally in an emergency. That's enough to keep your phone alive for over 18 hours of standby using your car's energy buffer. Apple's iPhone Fold, in contrast, will likely remain confined within the iCloud ecosystem. Sure, it'll sync perfectly with Macs and iPads, but Tesla's network extends far beyond screens. It extends into energy itself. That's where the two philosophies diverge completely. Apple builds for the digital world. Tesla builds for the physical one. So, what do you think? Would you trust a car company to build your next smartphone? Do you care more about Apple's ecosystem or Tesla's toughness and power-sharing tech? And most importantly, which foldable would you actually buy when both hit the shelves next year? If you found this breakdown useful, don't forget to hit like, subscribe, and turn on the bell icon, so you won't miss our next deep dive when we cover how Tesla's Pi Fold might link directly with Starlink and your vehicle's onboard AI.